Hello, my dear students and the rest of the learners. Welcome to part 11 of a 29-part series of tutorials in Fundamentals of Structured Programming using C. In this tutorial, we are going to be looking at what we call the switch selection control structure, or the last set, or the last type of selection control structure by the name switch. My name is Memory M, or you can simply call me Emily Swap. What is a switch structure or a statement, and how do we use it? This is a structure used to make a decision as to which action to take based on the various available options in a similar fashion as the nested if. In other words, switch is a short form of the nested if control structure. It works in a situation where there are several options or several conditions to be checked, and an action is taken based on the condition that is met. It is used to perform multiple selection. It is thus used in a situation where there are many options to choose from based on the condition that has been met. It consists of a series of case labels, an optional default case, and the statements to execute for each case. The keyword switch or case is usually followed by the variable name or expression called the controlling expression. This is because its value is compared with each of the case labels. If a match occurs, the statements for that case are executed. Then the switch or case statement is executed immediately with a break statement, that is break. In other words, my dear students and the rest of the learners, within switch, we have several cases. A case is simply like a situation or a condition that is being met. A value is checked. If the value that has resulted from an expression equates to the value within that section of the code, the statements within that section are executed. And once the last statement within that section is executed, the program exits the selection control structure because it encounters the word break. The break statement causes program control to continue with the first statement after the switch statement. Its flowchart and general logic of switch is similar to that of nested if, and that's why in this presentation, we are not going to redraw the control structure, that is the flowchart for the case or for the switch structure, because it is similar to the one which we discussed in part 10 of the series. And therefore, if you don't know how to construct or to draw a flowchart as well as pseudocode for the nested if, which is similar to the case one, I would kindly request you to visit part 10 of the series, which has been posted in Emeriswap ICT YouTube channel, so that you can be able to familiarize yourself with how the pseudocode looks like and how the flowchart looks like, because the pseudocode and the flowchart for switch are similar to those of the nested if control structure. So the selection is based upon the current value of an expression, which can only be expressed using integers and alphabetic characters only, and this result is called a selector. This means that the value generated from an expression to be used in the selection of an option while using switch must be rounded off if it's a real number so that it becomes an integer. In other words, the switch statements of the switch control works with a result that results, or a value that results from an expression. That is the result, or that's a value which determines which section of the control structure will be executed. The ceil or floor function is used to convert a real value to an integer so that we can then use it in our selector or as our selector. For example, if using miniscore, or if you want to use miniscore to determine the grade using switch, you are supposed to round the miniscore so that you can convert it to an integer as follows. So you have the statement, for example, ceil, which is the function for computing for rounding off. You have it ceil, then pass into it mean score, and the result which you are going to get, you assign them in mean or you can also use floor. If you don't know what these functions are all about and how they work, I kindly request you to visit MLSwap ICT YouTube channel, where you are going to learn about the inbuilt functions in one of the series that is already posted in the MLSwap ICT YouTube channel under the sub programs or the inbuilt functions. If a character is used as a selector instead of an integer, it should be represented as a character constant. A character constant is represented as the specific character in single quotes. For example, A. This control structure, that is the switch, is preferred to the nested if in order to reduce the many lines of code. Otherwise, the logic is the same. What is only difference is some syntax. The following is therefore the syntax for switch statement. We have switch expression, and then from that expression or from the value which is generated, we check. So we have case label 1. If the value that has resulted from the expression is able to meet or is fit within the case label 1, we take action 1 and come out of the control structure. Otherwise, if that section or that label is not met or that case is not met, we check the second case. If the second case is met or the value matches the label 2, we take action 2. Then we come out of the control structure. Otherwise, if the value does not match with label 1, it does not match with label 2, we check if it matches with label 3. If it matches with label 3, we perform action 3 and come out of control structure or out of that section. Otherwise, we continue checking which level matches the value from our expression or the last one. And then we add our program or we add our checks by having or executing the default action. Now, this default action is only taken if all the other cases or labels are not, or none of them matches the value of our expression. So if no action is taken at a case label 1, case label 2, case label 3, case label n, etc., then it's always good to have a statement informing the user what has happened. That's what we call the default action. And we add that switch. So that's a syntax. That's how we write it. So to help you, my dear students, and the rest of the learners gain more understanding on the same, we are going to see a source code for a program that accepts the radius. If the radius is less than 5, it calculates the perimeter and displays it on the screen. Otherwise, if that is not met, we check if the value of radius is between 5 and 10. And if that is true, the program calculates the area and displays it. Otherwise, if that is also not met, we check if the value entered is more than 10 but less than 15. And if that is true, we compute both the area and perimeter and display them. Otherwise, the program displays the message, the circle is too big, and the calculation can't be done. And therefore, my dear students and the rest of the learners, it's important to note that this program is similar to the program that we discussed in part 11 of this, in part 10 of the series. The only difference is the case part. So let's see how our program will look like. Now, the first statement is a comment, which informs the reader of the source code that this program calculates either area and/or perimeter based on the radius entered. Then we have the preprocessor directive there. And then because we are going to use an inbuilt function for months, for rounding off, we include the preprocessor directive that contains mathematical definitions for the functions, mathematical functions, which is math.h. Then we have our main function there, and our body here where we are setting memory location assigned called pi, and we are assigning to it the value 3.142 as a constant. Then we also declare or set memory locations assigned called radius, area, and perimeter, which is supposed to hold the value of type double. And then we also declare another memory location called radii, which is going to have value of type integer. And in fact, this is the value which we are going to be using in our case. And then we have the statement displayed on the screen, requesting the user to enter radius of a circle. Then within that value, the value is stored in memory location called radius. From there, we route the value. We route the value which has been entered by the user. So because we are going to use case, it's always good to route the value which has been entered, because the user might enter a value with a decimal point, but case does not deal with values with decimal points. So it's always good to route them, route the value entered using the function, for example, floor, and the result is assigned in the memory location called radii. Then from there now, we can be able to use that value, which is an integer, perform our actions or do our checks. So switch radii. So use the value which is stored in memory location called radii to do the following. If the value entered is between 0, or the value in memory location called radii is between either 0, 1, 2, 3, or 4, that means any value in between 0 to 4, then compute the perimeter using this expression and display it on the screen as follows. Then come out of that switch section and perform other activities. Otherwise, if the result or if the value in radii does not match with the 0, 1, 2, 3, or 4, check if it matches with value 5, 6, 7, 8, 9, or 10. If the yes is a match, for example, 7, then the program will compute the area and display it on the screen using that statement, and then come out of the switch structure. Otherwise, check if the value matches value 11, 12, 13, or 14. If the value of radii matches with the value 11, 12, 13, or 14. If there's a match, compute the area using that expression, compute perimeter using that expression, then display the area and the perimeter of that circle on the screen. And just as we have said, this is an error, which needs correction. So let's correct this, because this is a repeat. This is a repeat, so we can erase that. And you can now see we have computed area, then we compute perimeter, then we display the area using that statement, and also perimeter using that statement. And once we do that, we tell the compiler or the processor to come out of the case or the switch structure to perform other activities. Otherwise, if the value does also not match between or does not range between 11, 12, 13, or 14, or there's no match, then we attend the process and display this default message on the screen that this circle is too big and the calculation can be done, and end the program, turn the control back to the operating system, and end our program. So let's code this program in our CNData or in our Falcon IDE so that we see how it will behave. So what we are going to do, as usual, we are going to launch our Falcon. We are going to launch our Falcon IDE there. And then we create our project. Our project is going to begin by clicking on empty project, then we click next. Then the name of our project will be switch. We can call it switch structure. The compiler type is C. We click on finish. Then we create our file here. We rename it. Let's call it switch. Then we can have our program here. Remember, we have already discussed this program, this one. So we can type this program in our IDE here, or we can just copy it and paste it here. So this is our switch structure. And you can see we have case 0, 1, 2, 3, just as we have discussed. So that's our program. So you can save it. You can save that structure, that project, the file, by giving it a name and clicking on save. Then we can now compile our program. You can see our compilation is successful. So we expect this program, when we run it, that it is going to behave the same way. The program which we coded in part 10 of the series. So let's enter. We are being prompted to enter the radius of the circle. So we can enter, for example, 3. Once we enter 3, you can see it computes the perimeter. That means the value of the radius matched with this. What about if we enter another value, like 6.38? You see, it will compute the area. So my dear students and the rest of the learners, this program works in the same way as part 10 of the series. So we can save all and exit from our program. And with that, my dear students and the rest of the learners, we have come to the end of part 11 of the series. You can proceed to part 12 of the series, in which you are going to learn about the introduction to looping and well-iterative control structure. Congratulations for learning part 12 of 29 on switch selection and control structure in fundamentals of structured programming using C. You can access the rest of the parts in the series, as well as other computer or ICT videos, by clicking or tapping on the Meliswap ICT YouTube channel below this video. To subscribe to the channel, tap on subscribe button below this video in YouTube if it's not currently reading as subscribed. For any further correspondence, kindly write to us through the email meliswap@gmail.com. Thank you very much for listening to me. Let's meet in part 13 of the series, in which we are going to learn about the looping control structures. God bless.